Assalamualaikum warahmatullahi wabarakatuh and hi. I am Afif Zakwan bin Zain from Mechanical Engineering, and today I will be presenting about fluid mechanics experiment which involves hydrostatic force and center of pressure. So firstly is the introduction. So what is hydrostatic force? Hydrostatic forces are the resultant force caused by the pressure loading of a liquid acting on a submerged surface. The calculation of hydrostatic forces and the location of the center of pressure are fundamental subjects in fluid mechanics. So the center of pressure is a point on the immersed surface at which the resultant hydrostatic pressure force acts. So why are we doing this experiment? So the objective is to determine the position of the center of pressure on the rectangular face of the toroid, which is the apparatus used in this experiment. So moving on to methodology. So the hydrostatic force and center of pressure acting on a vertical surface will be determined by increasing the water depth in the apparatus water tank and by reaching an equilibrium condition between the moments acting on the balance arm of the test apparatus. The forces which create these moments are the weight applied to the balance arm and the hydrostatic force on the vertical surfaces. So moving on to the procedures of this experiment. Firstly is the width and the depth of the rectangular face of the toroid were measured. Secondly, the length of from the pivot to the load hanger was also measured. Third, the 3-foot screws were adjusted until the apparatus is balanced. This will be indicated by the spirit level situated at the left base of the apparatus. Fourthly, the balance arm was adjusted until it is level by using the rider. Fifth, the tank was filled with water using the measuring cylinder to the zero scale datum. Next, the tank was filled with water again to a certain level about 1 centimeter from the top of the tank. And then the weights were placed on the load hanger to restore the balance arm to the horizontal position. Next, the weights on the load hanger were recorded and Y2 was measured. And it was repeated for at least 9 other values of weights. So this is the experimental setup of this experiment. So moving on to the data obtained from this experiment. So as you can see, as the weight increases, the depth Y2, which is from the surface of the water to the bottom part of the toroid, also increases. This is because the balance arm tilts as the weights increase, creating a moment. So as you can see too in this table, the center of pressure found was also increasing as the weights increase. And it has little to no difference to the theoretical value of center of pressure. So moving on to the discussion part. So hydrostatic pressure acting on the center of pressure counteracts with the weights and the two are directly related. As the weight grew larger, the moment about the pivot increased, as you can see by the dipping of the balance arm. So required this required the level of water to be decreased in order to create longer moment arm for the hydrostatic pressure of the water to counteract the force of the weight. So the forces on the curved surface can be broken into horizontal and vertical force. So these forces will counteract each other in the moment equation. Hence, the greater the weight, the deeper the position of center of pressure. So to conclude this experiment, we can see that there were some discrepancies between the theory and practice of this experiment, which maybe was caused by human error. Next, the fluid pressure was hydrostatic once the balance arm was horizontal. The water level needed to be lowered in order to counteract the increase in weight. Then the position of the center of pressure was able to be determined, and with this, the center of pressure is always below the center of gravity. With that, I thank you.